Hello everyone. Welcome to the another session on quantum computing. In this video, I am going to discuss about the Bloch Sphere. So you may get doubt why we need importance of Bloch Sphere, especially in the quantum computing. As we know that the qubit is the basic unit of information in the quantum computing. It can exist in the states 0 or 1 or in superposition of both. That is the advantage of qubit. But the representation of the qubit involves the complex quantities, complex parameters like alpha, beta. Here alpha, beta are the probability amplitude. And it is described by a vector in two-dimensional complex space, which is not easy to imagine. Therefore, to represent or to understand the operations of the qubit in easy way, the Bloch introduced the Bloch sphere concept, which is like a visualization tool of single qubit. Here, each and every state is represented as a point on the sphere. So, which is one of the easiest tool or concept to understand the qubit in a simple way. For example, in this is like a sphere, and here the point on the sphere is represented as the psi here. So this is the qubit position, and whatever the operations on the qubit is, it rotate the state vector on the psi. So which is one of the easiest way to understand the qubit position and operations on the qubit. This is the speciality of the Bloch sphere. So therefore, the Bloch sphere is a three-dimensional geometrical model used to represent the state of single qubit. And it represented as points on the surface of a sphere. As discussed, the qubit is nothing but it is a superposition of two base states like 0 and 1. Psi equivalents to alpha 0 and beta 1. Here, alpha and beta are the complex quantities. So the representation and understanding of qubit mathematical weight is different or difficult, and it follows the normalization condition like alpha square plus beta square equivalents to 1. And operations on this particular qubits representation alone is little bit complex for the beginners. That's what, to represent or to make it easy for everyone, and it is represented as a visual point of view, we use the Bloch sphere. So the Bloch sphere helps show all these possible states as points on the surface of a unit sphere. This representation is very helpful because the quantum gates can be understood as rotation of that particular point around the sphere. Therefore, the Bloch sphere provides a clear and mathematical representation how qubits behave either alone or quantum gates operate on that particular state. So this is like a sphere, like a three-dimensional sphere. This is the point relate to the state vector psi. We need to take it as like this is the x-axis, and this is the y-axis, and this is the z-axis. This is like a sphere, and the point relate to the particular state, quantum state, is represented as a point on the Bloch sphere. See here, this is the quantum state. This point is making two different angles. One is with the z-axis, one is with the x-axis, but this is the state position, state vector from the origin, and the projection of that particular state on the XY plane is this one. This projection is making angle pi with the x-axis. That part I will discuss within minutes. And this is the how the state is rotated with the quantum operations. For example, if the x gate is operate on the psi. So here, similar to the classical gates, NOT, NAND, NOR, we have Pauli's gates. So X gate, if operate on the state 0, what will happen? If X gate operate on the state 1, what will happen? That part we can understand in this particular figure as part of rotations. So this Bloch sphere helps us visualize the qubit state. We can easy to see the qubit state on the surface of the sphere, which is, if without Bloch sphere, it is very complex in understanding the state psi. Understand the superposition. For example, this point is taken as alone like state 0. Here this point is alone like state 1, but this point is the superposition of both 0 and 1. So understand the superposition, and we can observe the quantum gate operations as rotation on the sphere. What will happen if this state is operated by the X gate? What happened if this state is operated by the X gate or the Y gate or the Z gate? The gate information will be shared in another video, but there is a possibility to understand what will happen if any specific gate is operate on the particular site. Is there any changes is happen on that particular state that can be seen as rotation on the sphere. So if you want to understand the complete position representation, the Bloch proposed a model like psi equivalents to cos theta by 2 plus e power I phi into sine theta by 2. Here it is like state 0. Here it's like state 1. This is the representation. For example, this in the Bloch sphere, this is the north pole represents the state 0 because theta is 0 here. Whatever the state vector, if you take in this point, this is the representation of the state vector related to the particular state psi. Then theta is 0. When you apply theta on this, then obviously cos theta by 2, cos 0 by 2, cos 0 is 1, state 0. Here it is 0, state 1. So this is the representation position related to the state 0. Similarly, this is the state 1. Like theta is 180 degrees. So 180 degrees, but phi is 0. Phi is 0 on this particular position. Then this parameter cos 90 is 0, but sin 90 is 1. E power I into phi, e power 0 is 1. Then this is the relation related to the state 1. So other than these two, north and south pole, each and every position on the sphere is like a superposition state. So the common formula of qubit using the Bloch sphere, then state psi equivalents to cos theta by 2 state 0 plus e power I phi sin theta by 2 state 1. So here we are using the two angles. One is the polar angle, second one is the azimuthal angle in representation of the quantum state on the surface of the Bloch sphere. So these angles is measured like the polar angle theta is measured from the positive x-axis, positive z-axis towards the qubit state vector. Similarly, the azimuthal angle is measured in the xy plane after projecting the state vector onto that plane, and it is measured from the positive x-axis. The angle between the projected state vector in the xy plane with the positive x-axis is the phi. So if you want to represent the quantum state on the Bloch sphere, we need the two angles. One is the polar angle, second one is the azimuthal angle. Then angle theta, like a polar angle, represent or gives the information about the vertical position of the qubit and probability distribution between the states 0 and 1. Because as discussed, it is like superposition is changes, alpha beta is changes. Here the alpha beta are the probability amplitude. Then obviously it gives the information about the probability distribution between the states 0 and 1. But azimuthal angle tells us about the rotation orientation around the z-axis and quantum phase information. As we know that the rotation relate to the polar angle from upside to the downside like this. So this is the angle in between the 0 to pi, either 0 and pi, or in between the 0 less than or equivalent to theta is less than or equivalent to phi, determines the position between the 0 and 1. Whereas azimuthal angle is like a this kind of rotation around the z-axis in between the 0 to 2 pi, determines the relative phase of the superposition. For example, this is the sphere. This is like a sphere. This point, this I mentioned like this is the x-axis and it is the y-axis, and this is take it as like a z-axis. This particular point is represented as the state 0. This particular point is represented as state 1. And this point, in what way we can represent this point? So then obviously if you want to measure this particular state along the y-axis, this is the state psi. Then obviously the angle between these two is take it as pi by 2 is theta. Then similarly, if you want to measure the phi, this is also phi by 2 because this particular projection on the same plane. Here if you want to represent this point, we need to consider the theta equivalents to phi by 2 and the azimuthal angle is also phi by 2 because the point phi is measured the projection of the particular state vector and the projection state vector making angle with the positive x-axis, that is the phi. So both the theta phi by 2 and phi by 2, if you apply to represent the state psi at this point, so phi equivalents to sine theta by 2, cos theta by 2 state 0 plus e I power phi sine theta by 2 state 1. So after representing this point, then state psi equivalents to 1 by root 2 state 0 plus I by root 2 state 1. This is the point related to this. Similarly, we can represent any position on the Bloch sphere by take it as the general qubit state like psi equivalents to cos theta by 2 state 0 plus e power I phi sine theta by 2 state 1. Here we need to take care about the measurement angles related to the theta and the phi. This is the representation of the qubit states on the Bloch sphere. And coming to the how the quantum gates operate on the Bloch sphere. For example, just I'm taking as an example related X gate, Pauli's X gate. It is represented by the matrix like 0, 1. The complete details about the Pauli gate will be discussed in the another video. Just to understand what will happen if quantum gate is operated on the particular state I'm showing here. This X gate is nothing but 0, 1, 1, 0. And as we know that state 0 is related to the matrix point of view 1, 0. State 1 is related to the 0, 1. I want to check what will happen if the X gate is operate on the state 0. See here, 0, 1, 1, 0, and then 1, 0. 0 into 1, 0, 1 into 0, 0. 1 into 1, 1, plus 0 into 0, 0. So here, if X gate is operate on the state 0, but I am getting the state 1, flip. It flip the state 0 to 1 by operating the X gate. That is, if the state is operated by the X, it flips 180 degrees around the X-axis. Similarly, by applying the Y gate, it also flips 180 degrees with the rotation axis, Y-axis. Similarly, quantum gate operations can be understood visually as part of rotations on the Bloch sphere. So this is the speciality of the Bloch sphere in quantum computing. Thank you.